this question, or this part of the question from the pilot 2012, what we're asked to do is use our line of best fit to find the time period of Mars, given that Mars is an average distance of 228 million kilometers from the Sun. So first thing we need to do is convert 228, get the logarithm of that, then we can look it up on the x-axis. So ln of 228 is approximately equal to 5.43. So what we need to do is on our x-axis here, look up 5.43 and draw a line straight up to hit our line of best fit. From there, we then draw a line across to the y-axis here and get our value out. And that, remembering the increments on the y-axis are going up in 0.2s, so that's about 6.6. So what we're saying is the ln of t, equals 6.6. So to actually find the value of t, we can say t equals e to the 6.6. So t is approximately equal to 735. So to write it out then in full, we can say period of Mars is approximately 735 days. That's all that's needed for that part of the question. For the next part of the question, we're asked to use our graph or otherwise to find the values of a and k. And we've already linearized this equation. So if I write that down again, we've got, taken our original equation up here, we're going to linearize it. We had the ln of t equals the ln of a plus k ln of d. And what that's quite nice to do is write down underneath that our standard equation for the line, our y equals mx plus c, but really our x is this ln d, so actually we could write it as y equals c plus mx. So it's quite nice, we can see then that k would match to m, the gradient, and ln a would match to c, the y-intercept. So let's calculate the gradient and the y-intercept. First thing to do then, let's bring our table back in. Before, this will help us calculate our values. And what we're going to do is do a triangle in here, take these points and do a triangle. I've chosen those because we were given those initially in the question, but in case I've made any mistakes calculating these. So let's work out this height here. This top point here is reading across there, that's going to be our 8.37. Our lower point will be our 4.48. So 8.37 minus the 4.48 means that that height there is 3.89. Okay, similarly on the x here, this point here is 4.06 and this point here is 6.66. So 6.66 minus 4.06 gives us that distance along there as being 2.6. So some space up here, we can say the gradient, rise over run, so it's 3.89 divided by 2.6, which to three significant figures, well actually we could say that's well, it's 1.496, so we can write that as 1.50 if we're going to do three significant figures. And that gradient then is going to correspond to k, because remember the gradient is corresponding to 0. So we can say, therefore, k is approximately equal to 1.5. Right, C then will give us our y-intercept. Well, our y-intercept down here, this is minus 1.6. So what we can say is that the ln of A, the ln of A equals minus 1.6. So A is going to actually equal e to the minus 1.6, which is approximately 0.202. So we've got A equaling 0.202 and K equaling 1.5, and that's all that's required for this part of the question.